presentation.
Thank you, Eva, for the introduction. Einstein, in a letter to a colleague, famously wrote, "I'm convinced that he," and he meant God, "does not play dice." And what did he mean with this? Quantum mechanics, the theory of atoms and light, had been immensely successful, but it was also very weird. For instance, take the simplest atom, hydrogen. Just one electron moving around the proton. Quantum mechanics couldn't even tell you where the electron was, just the probability to find it somewhere. Einstein didn't like that. He thought that a good theory should give you precise predictions, just as Newton's theory tells you exactly where the moon is in its orbit around the Earth at every moment. Not everybody agreed. Here are two of the founding fathers of quantum mechanics, Niels Bohr and Edwin Schrödinger. They thought that quantum mechanics was okay as it was, didn't need anything more, you just have to accept the peculiarities. And this position was put very clearly in this paper written in 1935 by Edwin Schrödinger. It was an answer to a paper written earlier that year by Einstein, Boris Podolsky, and Nathan Rosen. And they had come up with the thought experiments, which they thought proved, demonstrated that quantum mechanics couldn't be the full story. And now I will explain to you a modern version of that experiment. So here you see a source. This source emits pairs of particles, entangled pairs, Bell pairs. We'll come back to that concept. And they reach Alice and Bob, who makes measurement. They measure a property of these particles that is called spin. And in quantum mechanics, this spin can only take two values, plus or minus. So what happens when you do it many times? Alice will see a sequence of pluses and minuses, plus, minus, plus, plus, minus, minus, plus, etc. Looks completely random. And the same is true for Bob. But the strange thing is that when they compare the measurements, every time Alice sees a plus, Bob will see a minus, and vice versa. And that's very strange, because they are far away from each other, and these particles look exactly the same. Well, perhaps, let's look at it. Here we have the quantum cards. They look all the same, huh? We shuffle them or entangle them, and then here they go. And they can answer questions on signs. What sign do you have? Plus? What sign do you have? Minus. Okay? Let's take another set of quantum cards. Here they go. What sign? Plus. What sign? Minus. Strange. They look the same. How could they know what sign they have? Well, you see, here it is a trick. That is the following thing. Look, that was a minus, and that was a plus. So each entangled pair had one plus and one minus. I know where the minus went there or there, but it was always one plus and one minus. So, could it be that quantum mechanics was the same? Could it be that there were hidden informations like on the cards? Could it be that nature was a trickster? Okay, just like I was before. Perhaps quantum mechanics is not complete. Perhaps there is something hidden. Einstein would have liked that.